Wherever you are right now, I hope you are comfortable, perhaps lying down, perhaps sitting in a quiet corner, or simply letting your breath settle into its natural rhythm. Tonight, we drift into a quiet world, a world where something as small and ordinary as a leaf becomes a doorway into a deeper, slower mathematics. Not the mathematics of equations written on a blackboard, but the mathematics that sits quietly in nature, written in shapes, in stillness, and in the gentle conversations between matter and the laws that govern it. Let your shoulders soften if they feel heavy, let your jaw relax, let the space around you feel safe, dim, and as calming as a silent forest floor, because that is where our journey begins, not in a lecture hall, but in a forest at night. Picture the scene. It is long past sunset. The day's final colors have dissolved into a deep, moonlit blue. A thin breath of wind moves through the tall trees, stirring their branches in slow, sweeping arcs. Eventually, even that fades, and the forest settles into the kind of quiet only nighttime can create. Most people would say that nothing is happening here, but tonight, we choose to see the world differently. Tonight, we are interested in what happens when nothing seems to be happening. In the center of this quiet forest floor rests a single leaf, a small, delicate green fragment of a much larger system. Maybe it has fallen recently. Maybe it carries the faint scent of chlorophyll still lingering in its veins. Maybe it is crisp, dried by time, curled ever so slightly at the edges. It lies there in complete stillness. But in that stillness lies a hidden universe of structure that mathematics can describe with elegance, precision, and even poetry. The silence of a leaf is not empty, it is full of invisible forms. For just a moment, imagine you could shrink down smaller and smaller, past the width of a hair, past the cells, past the intricate tunnels of chloroplasts, down to a place where the leaf transforms from something familiar into a system of geometric networks, a place where veins become branching algorithms, where edges become curves that follow rules older than language, and where silence is nothing more than the absence of vibration in a world that is always vibrating. And yet, even at our normal scale, the leaf's silence is meaningful. To us, silence often implies inactivity, but in nature, silence is sometimes the surface expression of a long, slow balance between forces. A leaf lying still on the ground is not merely an object at rest. It is a perfect equilibrium between gravity, friction, structure, and the shape it inherited from the tree above. Tonight we explore what this stillness can teach us, how its silence is not a lack of motion, but a form of mathematical completion. To understand the mathematics of a leaf's silence, we begin with the shape itself. Every vein, every curve, every angle is the outcome of biological optimization. Trees do not design leaves at random. They grow according to rules built into their evolution. If you look closely at the branching patterns of leaf veins, they resemble something familiar: rivers splitting into smaller streams, lightning stretching across the sky, or neurons branching through the human brain. Each follows a mathematical principle called minimization of energy, adopting the form that uses the least material to achieve the most function. This is why leaves often follow a fractal-like pattern. Their veins branch and rebranch, each subdivision achieving a delicate balance, supplying nutrients efficiently, reinforcing structure without unnecessary weight, and maximizing surface area for capturing sunlight. These patterns were not invented. They emerged naturally through millions of years of evolutionary problem-solving. Even in silence, the leaf remembers these rules. When you observe its edge, smooth or serrated, you encounter another mathematical idea: the curve. Leaves often approximate a shape called an ellipse, or sometimes a modified version of a Goldberg curve, or even a biological analog of the phi spiral, shaped by the golden ratio. These forms are not copied from geometry textbooks. They arise because nature operates under physical constraints: how water flows through cells, how sunlight strikes the surface, how the leaf must support itself without tearing. Even the most delicate shape is the result of forces negotiating with each other. And then there is the silence itself, the stillness of the leaf waiting on the forest floor. At first glance, silence seems like nothing to study, but in physics and mathematics, silence is simply a limit case of motion. It means everything that could vibrate, sway, or flutter has reached equilibrium. The wind is not pushing. The air pressure is uniform. The leaf is supported by the ground. its weight balanced by the friction beneath it. Stillness is the moment when competing forces agree to pause. To describe this mathematically, we turn to something called mechanical equilibrium. It tells us that an object is at rest when the net forces acting upon it equal zero. The leaf does not float or drift because gravity pulls downward while the ground pushes back upward. The ground resists sliding because friction locks it in place. And the leaf will only move again if one of these forces changes, if the wind picks up, or if a raindrop falls, or if an insect wanders across its surface. Thus, even silence is a system of relationships. Tonight we slow down enough to see these things, not through formulas, not through diagrams, but through patient observation. Through the same quiet attention that a forest keeps by default, the leaf's silence becomes a mirror, reflecting back the subtle mathematics that surrounds us all the time. Balance, pattern, repetition, energy, symmetry, and every small decision nature makes to maintain coherence. As the moonlight glows faintly on its surface, the leaf becomes more than a piece of plant tissue. It becomes a story written in geometry, a story of growth, survival, and shapes honed by time, a story of billions of atoms arranged into a structure that holds together effortlessly, even in rest, a story of silence that is not emptiness, but order. Later in this journey, we will explore how the leaf grows according to differential equations that describe the flow of nutrients, how its veins reflect fractal mathematics used in computer networks, how its curvature reflects solutions to energy minimization problems found in architecture, and how even the quiet decay of a fallen leaf follows statistical laws. But for now, we rest with this first image, a leaf lying on the forest floor, silent yet full of quiet geometry, resting in moonlight. A perfect, still moment that invites us to slow our thoughts, deepen our breath, and enter the calm world where mathematics and nature whisper to each other in shapes. In this gentleness, we begin. Crescent Moon Image, Prompts for Part 1. Below are the prompts following all your image rules: nighttime, calm, cinematic, ultra-realistic, soft lighting, slight haze. The first several prompts, the hook, are more creative and visually striking. The rest shift into consistent, calm realism. Take a slow, gentle breath in and out, letting the rhythm of your body settle into the same natural calm the forest seems to hold without effort. As we continue our journey through the mathematics of a leaf's silence, imagine once more that moonlit forest floor. The leaf we observed earlier still lies there, quiet as before, but now we begin to look not only at its shape, but at its history, the long, patient mathematics that guided its growth from a tiny bud to the still, perfect form it holds now. Growth is never rushed in nature. It unfolds gradually, with unhurried precision, guided by patterns that remain hidden unless we choose to see them. Tonight, we choose to see them. In the earliest moments of a leaf's life, long before it fell to the ground, it began as a subtle swelling of tissue at the edge of a bud, no larger than the head of a pin. Yet even in this tiny beginning, mathematics was present. The cells that would one day form veins, blades, and edges started arranging themselves according to gradients of hormones, flows of nutrients, and pressures that acted like invisible instructions. This early growth follows something scientists call a morphogen gradient, a concept used to describe how chemical concentrations guide tissue development. Where the gradient is high, cells divide. Where it is low, cells stretch or specialize. And in between, complex shapes begin to emerge. Imagine these gradients as soft, invisible hills of concentration. Cells climb them, respond to them, and arrange themselves accordingly. Over time, these gentle chemical slopes carve out the form we recognize as a leaf, not by force, not by sudden leaps, but through slow, continuous decisions, each one mathematically guided. But growth is never a single event. It is a dialogue between forces. A leaf expands outward through the calculus of gradients, meaning its shape emerges from small changes accumulating over time, just as calculus describes change in the language of slopes and derivatives. When you hold a leaf and trace its outline with your eyes, you are tracing the final solution to a long, quiet equation written by nature. If we zoom inward, past the contours, past the cells, past the nuclei, we find this mathematics operating at an even more intimate scale. Inside each cell, tiny strands of cellulose align themselves carefully, forming microscopic fibers. These fibers determine how the leaf will stretch. They decide the direction of growth. They limit and guide expansion. And in their collective arrangement, we find something remarkable: tensile anisotropy, a scientific term meaning that the leaf does not grow equally in all directions. Instead, it grows primarily along certain axes, like a fabric stretching more in one direction than the other. This directional growth contributes to one of the most calming structures in all of nature, the gentle curve. A curve is never accidental. It is the outcome of thousands of cells expanding more in one direction than another. In mathematics, such curves can be described through differential geometry, the same field that describes the bending of light, the shapes of planets, and even the curvature of space-time. Yet here it is, quietly holding together a simple leaf. This is one of nature's signatures. The same mathematical rules operate across vastly different scales, from galaxies to leaves, and the leaf does not feel rushed. It grows slowly, responding to sun, wind, nutrient flow, and mechanical pressure. Its shape is the memory of its experience. As we think about this, return to the leaf resting in silence on the forest floor. The curves we see now, soft, natural, gentle, were once shaped by the forces of growth, and where the growth was uneven, tiny folds formed. Where tension was balanced, smooth surfaces emerged. Where supporting veins thickened, troughs and ridges took shape. Even when a leaf seems perfectly still, its shape carries the story of its dynamic past. The veins we noticed earlier have their own mathematics. They formed through a mechanism scientists call canalization, a process by which fluid flow strengthens the pathways it travels, reinforcing them over time. It's similar to how tiny rivulets in the ground eventually become streams, then rivers, carving paths that deepen as water repeatedly follows them. The flow of auxin, a plant hormone, acts like this water. Regions where the hormone flows the most become stronger, thicker pathways, veins. This is a feedback loop, where the flow reinforces the channel and the channel increases the flow. In mathematics, feedback loops often create branching networks, structures that minimize energy, maximize efficiency, and distribute resources evenly. Our leaf's veins are not random. They are solutions to optimization problems solved silently by the plant. If we step back again and imagine the leaf on the ground, illuminated by the moon, we now see it differently, not as a flat object, but as the outcome of 1,000 subtle decisions made over weeks and months. Each line in its surface is a record. Each tiny vein is a memoir. Each soft curve is a balancing of internal forces that reached quiet agreement. And this brings us to one of the leaf's most subtle forms of mathematics: symmetry. Most leaves exhibit bilateral symmetry, meaning one side mirrors the other. This symmetry is not perfect, but it is intentional. Nature prefers symmetries because they are stable, efficient, and resilient. Symmetry reduces the number of unique instructions needed to build a structure. Instead of designing two sides independently, evolution uses a copy and reflect strategy, like folding a piece of paper and cutting both halves with one motion. Symmetry brings calm. Our minds find comfort in it, and perhaps this is part of why looking at a leaf, even one lying still on the forest floor, can be so soothing. The symmetry we see resonates with the symmetry we seek internally: balance, order, calm. Yet nature also adds slight imperfections, tiny asymmetries that make each leaf unique. These irregularities form through interaction with wind, light, insects, stress, and inconsistencies in growth. Mathematics calls this perturbation, a gentle deviation from an ideal shape. Without perturbations, everything would look identical. But nature understands that perfection is not the goal, harmony is. And so the leaf grows, balancing symmetry and variation, tension and relaxation, pressure and expansion. A living structure guided by unseen equations, settling finally into silence when its journey is complete. Now, as we sit with this leaf, we begin to sense something profound, even in silence. The leaf is not separate from the mathematical forces that shaped it. It is simply in a state where those forces have balanced out, leaving only shape, form, and stillness behind. In the next part of our journey, we will explore how light influences leaf geometry, how patterns of sunlight and shadow dictate growth, and how the mathematics of surface area, fractal dimension, and energy capture determine the leaf's silent final form. For now, let us rest in this gentle understanding. The leaf stillness is the final expression of a long, careful, mathematically guided life. Wherever you are right now, let yourself settle a little deeper into comfort, letting your breath soften, letting your body grow just a bit heavier, and letting your mind drift gently back into the quiet forest we've been exploring together. The leaf before us has already revealed so much: its curves, its symmetry, the slow mathematics of its growth. Yet one of the most profound influences on its shape has not been examined closely enough just yet. Light. Not the light we see now under the soft silver wash of the moon, but the light that shaped the leaf's entire life. If growth is the language a leaf uses, then light is the voice it listens to. When that leaf was still high in the tree canopy, its form was sculpted by the shifting geometry of sunlight, a geometry that changed hour by hour, season by season. Light is not merely brightness, it is a flow of information. Each photon that landed on the leaf carried with it a message about direction, intensity, and opportunity. The leaf responded. It always responds. Plants possess a subtle sense of spatial awareness, a capacity to detect where light comes from and how much of it is available. This awareness arises through phototropism, a process in which cells on one side of the leaf elongate slightly more than those on the other, causing a gentle curvature toward light. To us, these adjustments seem invisible, too slow to notice. But over days and weeks, they produce graceful shifts in orientation and angle. If you could have watched this leaf's life played back on a time-lapse, from first emergence to its final green maturity, you would see it constantly adjusting, repositioning, negotiating with the sun. It would turn slightly at dawn toward the east, relax in the warmth of midday, and lean delicately westward as the sun lowered. Each movement, each tilt, each subtle shift was guided by mathematical optimization. The leaf seeks the most efficient angle for capturing light. Not too flat, because harsh sunlight could overheat its tissues. Not too steep, because too little light would starve it. Instead, it finds what mathematicians call an optimal compromise. In mathematics, optimizing means finding the best solution within a set of constraints. For the leaf, the constraints include heat, water loss, neighboring leaves, wind stress, and the architecture of the entire tree. And in every moment of daylight, the leaf balances these variables, quietly solving an equation that is never written down, yet always understood. This is the silent geometry of survival. If we look even closer, deeper into the structure of the leaf, we find yet another marvel of mathematics: surface area optimization. A leaf must present enough surface to capture sunlight, but not so much that it loses excessive water. It must be broad enough to intercept light efficiently, but not so large that wind tears it or boughs cannot support it. These constraints give rise to characteristic shapes, not randomly, but mathematically. Consider the elongated leaves of grasses, the broad palms of banana plants, the needle-like leaves of conifers, the gently serrated edges of maples, the rounded lobes of oaks. Each of these forms is a response to environment, a solution crafted slowly through millions of generations to a series of mathematical problems posed by climate, wind, temperature, and sun. Our leaf, lying on the forest floor, once solved these problems effortlessly. When sunlight filtered through the canopy above, the leaf made micro-adjustments to its growth, developing more chlorophyll where light was abundant, less where shade persisted. Over time, patterns formed, subtle gradients of green, slightly thicker regions where support was needed, specific angles that maximized the interception of scattered photons. All this performed silently, invisibly, without rush. And beneath the visible surface, an even more intricate geometry unfolds: the distribution of chloroplasts. These microscopic structures, responsible for capturing light energy, move within cells, repositioning themselves depending on brightness. In soft light, chloroplasts spread out to absorb as much as possible. In intense light, they align themselves vertically, reducing exposure to prevent damage. This internal choreography is astonishingly similar to the way solar panels adjust their orientation on a satellite. Except here, the machinery is biological, fluid, quiet. Imagine, for a moment, the leaf high above before it fell. Picture the warm light of afternoon filtering through other leaves, creating shifting mosaics of brightness and shadow. The leaf adjusts. Its chloroplasts reposition themselves like small dancers moving gracefully to a rhythm only they can hear. This slow, deliberate repositioning is a kind of silent communication, a response to environmental calculus. While all this happens, the leaf never loses sight of one essential truth. Sunlight is not constant. It arrives in pulses and waves. Clouds interfere. Breezes shuffle the canopy. Seasons tilt the angle of incoming light. The leaf must anticipate change. In its tissues, light-sensitive proteins act as sensors, detecting both intensity and wavelength. These sensors trigger responses, slowing growth here, encouraging it there, thickening certain cell walls, thinning others. Over time, the leaf becomes a record of the light it received. Its structure is a memory of how it lived. The wider lobes mark places where light was plentiful. Narrow regions hint at shaded areas. Thickened veins indicate stress or support needs. Pigment variations reveal past sun exposure. Even in its stillness now, long after it has ceased to grow, the leaf is a map, a topographic record of the geometry of light. And yet, all of this complexity exists within a single, simple truth. A leaf seeks balance. Balance between growth and restraint. Between expansion and support. Between sunlight captured and water conserved. Between mathematical possibility and biological necessity. This balance is guided by the physics of light, the biomechanics of growth, and the silent patience of nature. If we place the leaf back into our night forest scene, soft moonlight cascading gently over its surface, we can almost imagine the shadows it once cast, the photons it once held, the days when it basked quietly in the warmth of the sun. In the next part, we will drift even deeper into this interplay between structure and function. We will explore the mathematics of fractal branching, energy flow, and the astounding concept of self-similarity, patterns repeating within patterns, like echoes of nature's infinite creativity. For now, let your mind rest in this understanding. The leaf's geometry is a conversation with light, one that lasted its entire life, and one that remains etched into its silent final form. If you listen closely, not with your ears, but with that quiet place inside your mind that notices things, you will sense that the ocean is not only a body of water. It is also a body of memory. A single drop of seawater drifting in the moonlight carries, inside it, a story older than mountains, older than trees, older than the very sand beneath our feet. Imagine that drop now, floating, turning slowly in the soft cradle of the waves. Inside it, suspended like stars in miniature, are thousands of tiny beings. Plankton, invisible architects of life, drifting not because they are weak, but because drifting is their way of knowing the world. Each tiny creature a diatom, a radiolarian, a copepod, responds to sunlight, to chemical whispers, to the faint movements of surrounding water. They do not have brains, no neurons, no thoughts in the way you and I understand thoughts. Yet they calculate all the same. They solve problems. They sense danger. They seek nourishment. They choose where to rise, where to sink. Almost like a soft, slow conversation with the sea itself. Now picture this drop again, but zoom deeper. Down to the microscopic level. Down to the molecules. There you will find salts, minerals, nutrients, all arranged in patterns shaped not by chance, but by the ocean's long memory. Every current, every storm, every river that has ever met the sea has left a fingerprint on the water's chemistry. This is the ocean remembering, not with neurons, not with thoughts, but with patterns, patterns written into the drifting salt, the swirling plankton, the rising warmth and cooling depths. The ocean gathers information the way a field gathers wind. Quietly, patiently, without needing a mind, yet thinking all the same. The drop you imagined, that tiny sphere of ancient memory, will drift for days or months, traveling through invisible highways carved by tides. It might join the warm arms of a tropical current, or sink into the slow, dark underworld of the deep sea, where temperatures fall, pressure rises, and sunlight has never lived. Wherever it goes, the drop listens. It adjusts. It responds. And in doing so, it learns without ever knowing that it is learning. This is the quiet intelligence of water. An intelligence without identity, without self, without a story of its own. And yet, somehow, holding the story of the earth itself. In the next part, we will follow this drop as it sinks into the twilight zone, a place where the ocean thinks in currents, echoes, and shadows. Now let the light around you soften. Let it dim, as though you are descending with that tiny drop of water. Downly, downly, into the ocean's twilight zone. This region is neither bright nor fully dark. It is a place where colors surrender one by one, where blue becomes the last survivor, and then even blue begins to fade into a calming, endless dusk. Feel that shift, the slow cooling of the water, the hush of pressure increasing around you, the faint biological glow of creatures who carry their own lanterns inside their bodies. In this half-light, the ocean begins to think differently. Here there is no sunlight to guide life, no shimmering patterns at the surface, no obvious path to follow. And yet thousands of species move with confidence, as if following a map that no human has ever seen. Tiny silver fish gather in shimmering ribbons, turning left or right with such perfect unity that they seem less like individuals and more like a single organism, spread across hundreds of bodies. But there is no leader here, no command, no brain coordinating the dance. The intelligence exists in the space between them, in the physics of the water, in the pressure waves they send to one another, in the instinctive responses shaped by millions of years. Watch now, as your drifting drop of water becomes part of that flowing, silent communication. When a large shadow passes overhead, perhaps a hunting tuna, the school senses the disturbance through the subtlest ripples. They turn, they scatter, they reform. The ocean has just made a decision. Without a mind, deeper still, drifting downward like a falling snowflake, you meet creatures of quiet mystery. A comb jelly, its body like a glass lantern, throws soft rainbows into the darkness, as tiny hairs along its edges beat in mesmerizing waves. A squid, long and ghost pale, pulses past you. Its skin flickers with patterns, a language of color, used to confuse predators or send messages, or simply to feel its way through the dark. Everything here is information. Everything is signal. Everything is reaction and response, cause and effect. A delicate web of sensing and adjusting that keeps life in balance. The drop of water you have followed is no longer just drifting. It is participating, carrying oxygen, heat, nutrients, and chemical cues that will shape the decisions of countless beings. In the twilight zone, the ocean becomes a vast, slow-thinking creature, Not conscious, not alive in the way we understand, but aware in a deeper, older sense. Aware through currents, aware through chemistry, aware through the silent behaviors of the lives it holds. And as you feel that awareness around you, you realize something. The ocean does not think with a brain. It thinks with motion, with pressure, with light and the absence of light, with life itself. When you're ready, we will descend deeper into the midnight zone, where the ocean's thoughts become even slower, even darker, even more ancient. And now, as you continue drifting downward, the last traces of twilight loosen their grip. The dim blues dissolve, the soft silhouettes vanish, and you slip gently into the pure, enveloping quiet of the midnight zone. Here, light is not merely scarce. It is a memory, a rumor passed down by creatures who have never seen the sun, yet somehow carry in their bodies the instructions of ancestors who once lived closer to the surface. In this darkness, your senses shift, your thoughts slow, your awareness becomes delicate, as though you're listening not with your ears, but with the entire surface of your being. For a long moment, nothing moves. The silence is thick, like velvet wrapped gently around your shoulders. It feels ancient, as though you have stepped into the ocean's oldest cathedral. And then, from the far distance, a soft glow, a single point of blue, then another, then a chain of tiny lanterns, drifting like stars untethered from the sky. These are bioluminescent organisms, masters of living light. They wear brightness the way trees wear leaves, effortlessly, without hesitation, as if illumination were as natural as breathing. A small jelly, no bigger than your palm, pulses into view. Its body is nearly transparent, a floating droplet of glass, but inside faint sparks shimmer, twinkling like thoughts drifting across a sleeping mind. You follow the soft halo it casts, and soon you encounter a creature whose presence feels like a dream, a deep-sea anglerfish. Its long, luminous lure swings softly, a glowing pendulum guiding prey closer. Its body is shaped by darkness, its teeth like curved needles carved by evolution, to fit perfectly into one another. But even here, in this eerie beauty, nothing feels threatening. Everything moves slowly, carefully, thoughtfully in its own quiet way. The ocean, in this depth, is not thinking in quick pulses or sudden reactions. It thinks in centuries, in cold, steady patience. The drop of water you have followed carries almost no warmth now. It has shed its sunlight-born heat, like a traveler removing a coat before stepping into a colder, deeper world. As it moves, it brushes past drifting snow, not snow as you know it, but marine snow, tiny flakes of organic matter, falling from the sunlit world above. Each particle contains the memory of life, a fragment of a plankton cell, a piece of a drifting feather, the remains of a leaf blown into the ocean long ago. These quiet remnants slowly feed the ones who live in this darkness. Here in the midnight zone, life survives not by abundance, but by grace, the grace of accepting whatever drifts by. Whenever it drifts by, your drop of water becomes part of this slow rain. Its nutrients mix with the falling debris, carrying invisible meaning to creatures who have never seen the source of their food, only the soft, continuous gift of the surface world. And somewhere, far away in this silence, the shifting of continents creates a faint tremor, a whisper of geologic thought, the earth itself sending signals, through stone, through water, through the quiet spine of the ocean floor. You feel it subtly, not a sound, not a vibration, but a presence. The ocean listens to the earth. It listens to the moon. It listens to the stars tugging gently on its surface, through gravity's invisible chords. This is how it thinks, not with neurons, but with endless, fluid relationships. As you drift deeper still, the pressure grows immense, hugging, holding, as if the ocean were guiding you toward a place few beings have ever imagined. Ahead lies the abyssal plain, the vast, dark desert of the sea, a place where the ocean's thoughts stretch into the horizon, broad and calm and ancient. When you're ready, we will enter that silent expanse together. The descent becomes steadier now, as though the ocean itself has placed a hand on your back, guiding you gently, patiently, toward its quietest chamber. The midnight zone softens behind you, its flickers of blue bioluminescence fading, like the final stars before a moonless dawn. And ahead, spreading wider than deserts, deeper than mountains, older than any memory, lies the abyssal plain. Imagine a place so vast that it feels almost horizontal in every direction, despite curving gently around the planet. A place where darkness is not an absence, but a presence, a deep, consistent companion that wraps every grain of sediment in its patient embrace. Your drop of water settles here, not touching the bottom quite yet, but hovering, drifting, following a slow current that moves, not in hours but in centuries. Down here, the silence becomes structural, a kind of architecture made of stillness. Nothing rushes, nothing hurries. Everything is deliberate, like thoughts passing through the mind of a being who measures time in geological breaths. As your eyes adjust to the darkness, you begin to see shapes, not bright or defined, but subtle outlines, creatures adapted to a world where energy is precious and waste is unimaginable. A sea cucumber, long and soft, moves across the sediment with the calmness of a drifting cloud. Each step, if you can call it a step, is a thoughtful expansion, a patient contraction, a rhythm so slow you almost confuse it for stillness. Nearby, a brittle star spreads its thin arms like whispered lines in the sand. It feels vibrations rather than light, storytelling through touch rather than vision. And then, a creature that seems sculpted from the idea of darkness itself. The dumpling sea pig, plump, translucent, moving with tiny hydraulic feet. It looks almost comical. Yet here in the abyss, it is an emblem of efficiency, a master recycler, quietly cleaning the remains of the world above. These beings form the ocean, slowest, quietest thinking. Their movements stir the sediment, shaping the chemistry of the water. Their feeding patterns recycle carbon on scales so vast that they affect the entire planet's climate. Every grain of sand they shift is a syllable in the ocean's language. Every slow pulse, every drifting feeding tentacle is a thought stretched across miles of darkness. You drift further, and the drop of water you follow begins to mingle with the faint warmths rising from cracks in the Earth's crust. At first it seems like nothing, a whisper of heat in a kingdom of cold. But then you feel it. A pulse, a shimmer, a ghost of warmth, lifting through the water, like the world itself exhaling. These are hydrothermal hints, the first clues that beneath this quiet desert, the planet is not asleep at all, but alive with heat and fire. The currents here are ancient. Some molecules around you may not have touched the surface for hundreds of years. And yet, even in this seeming stillness, the ocean is busy. Busy in a way that does not resemble life at the surface. Busy in the way a mountain is busy. Slowly changing, slowly shaping, quietly influencing everything above it. On the abyssal plane, you begin to understand something profound. Silence is not emptiness. It is structure. It is order. It is the architecture of thought. In a world that does not need sound to communicate, ahead you sense a pull, a gentle invitation toward a deeper, stranger place, where darkness and fire coexist, a world of chimneys and mineral spires, of black smoke that feeds instead of harms, of creatures who rely not on sunlight, but on the chemistry of the earth. When you're ready, we will descend to the hydrothermal vents, where life discovers new ways to think. In complete darkness, the silence of the abyssal plane stretches behind you, a long exhale from a world that measures time, not in days or months, but in the slow drift of continents and the rise and fall of oceans. Now, your drop of water begins to feel something new, a faint stirring, a pull that seems to come, not from above, but from below. A gentle upward current, a thread of warmth, a shift so subtle that at first it feels like the ocean imagining movement, rather than creating it. But gradually the sensation strengthens, becoming unmistakable. Heat, not the warm, bright heat of sunlight, but the heavy mineral heat of the Earth's inner fire. You drift toward it, slowly, effortlessly, as if drawn by the heartbeat of the planet itself. And then, through the darkness, something begins to appear. At first, only shapes, tall silhouettes rising from the seafloor, columns, towers, chimneys, as though an underwater city has been carved from midnight stone. These are hydrothermal vents, black smokers, ancient mineral spires, built grain by grains, from water heated deep in the crust, and thrust upward like volcanic breath. As you drift closer, the darkness changes. It becomes textured, alive. Particles shimmer like sparks, floating upward in slow, weightless spirals. The vents emit water, so hot it could melt metal at the surface. Yet down here, under crushing pressure, it spreads outward like ink in water, a billowing plume of black. And it is inside this blackness, in this quiet cloud of chemical alchemy, that something miraculous happens. Life feeds on darkness. Life grows in silence. Life builds thought. From heat and minerals alone, tiny bacteria gather first. Simple ancient beings that convert the vent's chemical energy into nourishment. But these small creatures, are not merely surviving. They are transforming the ocean. They are shaping ecosystems. In a world without sunlight, as you drift among them, you feel their presence as a soft, invisible hum, a different kind of intelligence, one that predates sunlight, one that predates leaves, one that predates the very idea of eyes. A cluster of tube worms appears, their bodies stark white, their plumes an impossible red, a red so deep, it looks like velvet blooming in the darkness. They have no mouths, no stomachs, no way to feed themselves, in any conventional sense. Instead, they host the bacteria inside their bodies, tiny chemical thinkers that turn vent minerals into energy. The worms grow tall, crowded together like the pipes of a silent organ, each one glowing softly in the dim scattered light of bioluminescent particles. Nearby, ghostly crabs crawl across the mineral chimneys with slow, deliberate intention. Every movement is a negotiation, with the intense heat on one side and freezing water on the other. Each species living here, the worms, the crabs, the snails with armored scales made of iron, does not simply exist. They cooperate with chemistry. They create partnerships between heat and life, between rock and cell. This is the ocean thinking in deep time. This is thought without neurons, pattern without sound, awareness without eyes. Your drop of water now mingles with this chemical storm. A molecule of iron touches it, then a molecule of methane, then a burst of hydrogen sulfide, each one a tiny signal in the swirling conversation between Earth and life. And yet, nothing here rushes. Even the vents, though boiling with energy, release their heat in a slow, almost serene way, like ancient storytellers, unfurling tales one wisp at a time. Here, in the darkest place in the ocean, you begin to understand that life does not require light to begin. It requires gradients, differences, places where the world is not at equilibrium. And the ocean knows this. It feels these gradients, these tiny contrasts, and uses them the way a leaf uses sunlight. Thoughts forming in the quiet tension between hot and cold, between dark and darker, between stillness and flow. As the drop continues drifting, carried gently by vent plumes, it begins to rise again. Not quickly, just a subtle lift, a reminder that the ocean's thoughts travel in loops, not lines. Ahead lies a vast, open region, not the surface, not the depths, but the wandering space between them, where waters from different continents collide in slow, swirling spirals, a place where the ocean's long, slow thinking turns into global patterns, currents, climate, weather. When you're ready, we will rise into the great ocean conveyor, the slow pulse that quietly shapes the world above. The warmth of the vent fades behind you, like a final lantern in the distance, its glow dissolving into the dark, as your drop of water begins its slow ascent. At first, the rise is so gentle, you barely notice it. A slight lift, a faint suggestion of movement, as though the ocean is exhaling you upward, after holding you in its quiet lungs for a time. In this realm between abyss and surface, the water is neither hot nor cold. but layered in subtle gradients, delicate shifts in temperature and salt that decide the paths of currents, like the soft contours of a landscape, determining the direction of a wandering stream. Your drop joins a slow, wandering mass, a river inside the ocean, a river with no banks, no single direction, no clear beginning or end. This is the global conveyor belt, the vast thermohaline cycle that connects every ocean on Earth into a single intertwined pulse. If you listen carefully, not with ears, but with a kind of inner attentiveness, you can feel that pulse now, a gentle, ancient rhythm, the heartbeat of the planet's water. It is slow, so slow, in fact, that a single circuit of this conveyor can take 1,000 years, a millennium of drifting, of learning, of exchanging warmth and memory. With every sea on Earth, this drop of water is beginning that journey. You rise into a layer where water from the tropics meets water from the poles, warmth brushing against cold in a delicate balance that drives storms, seasons, rainfall, and drought, thousands of miles away. And here you sense something profound. The ocean's thoughts are not bound to the ocean. They travel the world. They become weather, climate, wind, life. A swirl begins to form around you. Not a storm. No, nothing so violent here. Moory like a slow-turning spiral. A gentle eddy spinning with the grace of a sleeping planet. Inside it, warm water drifts northward. Cold water sinks beneath it. Salt concentrates, dissolves, mixes, migrates. Each exchange is a message, a whisper carried across continents. Cold water from the Arctic slips downward like a thoughtful sigh, pulling surface water behind it, in a procession that spans entire hemispheres. Warm water from the equator rises in return, its energy feeding monsoons, and quiet rains, and the faint mist that forms at dawn. On the leaves of a quiet forest, you drift through these shifting pathways, like a traveler moving across invisible roads. Roads made not of stone, but of gradients, densities, and the memory of heat. Around you, microscopic plankton drift in vast numbers. They bloom and fade, in cycles driven by currents that began long before the first humans ever wondered about the sea. Their soft, fleeting lives change the chemistry of the air itself. When they flourish, they pull carbon from the sky. When they perish, they sink, becoming part of the marine snow that nourishes the depths, each one tiny, yet collectively powerful. Together, they are a quiet lung, breathing for the planet, not loudly, not with urgency, but with the slow patience of an ecosystem that understands the value of balance. You drift past a long chain of salps, delicate, gelatinous creatures, linked like transparent beads on a string. They pulse forward slowly, filtering the water, turning sunlight and nutrients into drifting motion. They are simple beings, yet they shape the flow of carbon through the ocean more profoundly than whales or sharks. It is here that the ocean's thinking feels almost mathematical. Patterns upon patterns, cycles within cycles, feedback loops so intricate that they seem less biological than algorithmic, an ancient computation, carried out with particles, currents, and the endless drift of life. And your drop of water is part of this computation now, a single variable in a vast fluid equation that balances climate on scales no human mind could hold at once. You can feel the world connecting. Each swirl of the conveyor pulls a thread from somewhere far away. A distant coast, a melting glacier, a storm brewing over warm seas, a gentle rainfall in a valley, where someone sits beside a window, hearing droplets tap like soft footsteps along the glass. All of it connected, all of it carried through these quiet, patient waters. Your drop drifts onward, joining a slow, broad current, moving toward continental shelves, coastal waters, and eventually, the sunlit world above. But before we rise, before the ocean returns your drop to the warmth of the upper layers, there is one more realm to explore. The world where deep meets shallow, where darkness meets light, where the ocean begins to bloom with color, yet still remembers the quiet thinking of the depths below. When you're ready, we will drift upward into the epipelagic homecoming, where sunlight returns and the ocean begins to awaken. If you are still awake, let your breath soften just a little more. And if sleep has begun to blur the edges of your awareness, that's perfectly fine. This part of our journey is meant to feel like drifting, floating, remembering. Because now we turn to a strange idea, one that scientists whisper about more often than they admit. The ocean remembers, not like a mind, not like a diary, but like a vast, patient archive of everything that has ever touched it. Let me explain. Imagine a single wave rolling toward a lonely beach at dusk. Its shape, the height, the curl, the softness of its collapse is not random. It is the final chapter of a story that began far, far away. A gust of wind, a passing storm, a shifting current deep beneath the surface. Every push, every pull, every whisper of energy transforms the wave. And the wave carries those transformations for hundreds, sometimes thousands of kilometers. So when a wave reaches your feet on the shore, you are touching a memory, a small echo of distant events. But the ocean remembers in even stranger ways. Consider salinity, the saltiness of the water. Every river that meets the sea leaves a signature. Every melting glacier writes its own chemical phrase. Every evaporating droplet alters the balance just slightly. And the ocean keeps these traces. Not forever, but long enough that a trained scientist can decode them like reading the faded ink of an ancient letter. Temperature, too, becomes memory. When the sun warms the surface, when cold currents rise from the abyss, when volcanic ridges exhale heat, the ocean records each change, layer by layer, season by season. Even organisms, tiny plankton drifting like stars in liquid space, become part of this memory. Their shells fall to the seafloor, collecting in silent layers that preserve entire climate histories, older than humanity itself. So when scientists say the ocean remembers, they mean that the ocean stores the consequences of everything touching it. Just as your breath carries the memory of your day. Just as your thoughts carry the memory of the world that shaped you. Just as each moment shapes the next. But the ocean's memory is different in one more way. It doesn't judge. It doesn't analyze. It doesn't react in anger or sorrow. It only records, quietly, endlessly, patiently. And perhaps that is why being near the ocean feels peaceful to many people. Because in a world where everything demands an opinion, the ocean simply witnesses. It watches the wind. It listens to the moon. It traces the path of storms and sunlight. And it carries these impressions across the world, like a soft, wandering thought that never stops moving. Take a moment. Imagine yourself standing on a silent shoreline. No crowds, no noise, just you and the rhythmic breath of the tide. Each wave that arrives has traveled farther than most humans ever will. Each one touches your toes and withdraws, not to forget you, but to carry the quiet memory of this moment back into the open water. And there is something profoundly comforting in that idea, that even the smallest moment of your existence can ripple outward into something vast. This is how the ocean remembers, not with neurons, but with motion, energy, chemistry, life, and silence. And as you breathe slowly, gently, you too are creating small waves inside yourself, the shifting currents of your own internal world. Let them settle, let them soften, let them drift into stillness. Because in part 11, we will explore something even more mysterious: how the ocean makes decisions without ever having a mind.